All right, for this first one, we have a choice. We can let u equal either x squared or natural log of x, but we know what the derivative of natural log of x is. So we're going to let u equal natural log of x. Now the derivative is 1 over x dx, and then we'll let dv equal the other one, which is x squared dx. So now we have everything taken care of. We got the natural log of x, the x squared, and the dx. V is 1/3 x to the third. So now integration by parts says we take u times v, so 1/3 x to the third minus integral of v du. So 1 over x times x to the third, that's x squared. So we have 1/3 x, x squared dx. And now we can actually take the antiderivative. So we have 1/3 x to the third minus. This is going to be 1/9 x to the third, and then plus c. Let's see, your second one. Second one is integral of sine of x and then cosine to the third of x dx. Well, this is a u substitution. We're going to let u equal cosine of x, and then du is negative sine of x dx. That's okay to have negative. We can always kind of, play around with that, because now, well, we have sine of x dx, but not negative. So let's just divide both sides by -1. So now we have sine of x dx. That's exactly what we have in here. So we got integral of negative du. So sine of x dx becomes negative du, and then we have u to the third. So this is negative 1/4 u to the fourth, and then plus c. So now we just make that replacement. We have negative 1/4 cosine to the fourth of x plus c, of course. That's 2a, actually. That's 2a. 2b. Oh boy, we got lots of stuff going on here. It looks like it's a little hard to read, but I think it's secant to the third x, tangent to the third x dx. And what they've done here on the key is we have secant squared of x, tangent squared of x times secant tangent of x. So that's still secant to the third and tangent to the third. And then we get everything in terms of secant. Well, your Pythagorean identity, I think I'll write it over here. Pythagorean identity is secant squared x is equal to tangent squared x plus 1. And that comes from cosine squared plus sine squared is equal to 1. So if you divide everything by, let's see, 1 over cosine. So everything by cosine squared, there you get the 1. Sine over cosine's tangent, and 1 over cosine secant squared. So, and then we can minus that 1 over. So tangent squared is the same thing as secant squared minus 1. We have secant x, tangent of x dx. Well, now we can let u equal secant, and then the derivative is secant tangent. And then we can make a bunch of replacements. So those secants become the u's. So u squared times u squared minus 1, and then the derivative is secant tangent. So this becomes du. And then we can distribute, that's u to the fourth minus u squared du, and then take the antiderivative, which is, we finally have something we can take the antiderivative of. 1/3 u to the third, and then plus c. And so u is secant. This is 1/5 secant to the fifth x minus 1/3 secant to the third of x plus c. All right, that takes care of a few of them anyway. Let's see what else we have. That's 2b on this key. And let's see, 2a and 2b. Let's look at c. Letter C. Integral of sine to, is that squared? I think it's sine squared x, cosine squared x dx. Well, they're using the double angle formula for cosine. Cosine of 2x is equal to, one of them is cosine squared x minus sine squared x. And we can write that as cosine of 2x is equal to, cosine squared is the same as 1 minus sine squared x. So we can write this as 1 minus sine squared x. These things keep popping up. Minus sine squared x. Well, that's equal to 1 minus 2 sine squared x. So cosine of 2x is equal to that. Well, now we can minus 1. Cosine of 2x minus 1 is equal to negative 2 sine squared x, and divide by negative 2. So sine squared x is the same as, and do they use the negative? Let's see, they reverse that. So they actually, when we divide by negative 2, we can do 1/2, and then if you take the negative out, then it's 1 minus cosine of 2x. I'm trying to write it exactly like it says on that key. Now this is called power reduction, because if I write this a little neater, you can take sine squared x, something squared, and turn it into something that is not squared. Cosine 2x, that's not squared. So now sine squared can be replaced with 1/2 of 1 minus cosine of 2x. And then likewise, if we have cosine of 2x is also equal to, we can replace sine squared with 1 minus cosine squared. So we have cosine squared x minus 1 minus cosine squared x. Well, that's equal to 2 cosine squared x minus 1. All right, so that's cosine of 2x. Add 1, cosine of 2x, plus 1 is equal to 2 cosine squared of x. And then divide by 1/2. So we can write this as 1/2 of cosine of, we actually turn that around. It's plus, so it doesn't really matter how we write this. But we're trying to make what's called, the difference of two squares. So 1 plus cosine of 2x is equal to cosine squared of x. So now the cosine squared can be replaced with 1/2 of 1 plus cosine of 2x dx. Well, 1/2 times 1/2 is 1/4, and we can pull constants out, 1/4. And then when we FOIL these two together, we get 1 minus cosine squared of 2x dx. Well, now we're going to do power reduction again, and we're trying to replace cosine squares. Let's write this a little neater. Cosine squared x is equal to 1/2, and then this is 1 plus cosine of 2x. But we have cosine squared of 2x. This says cosine squared of x. Well, we can replace the x with 2x. So we'll replace that with 2x, and we can replace this with this x with 2x, and that's going to make it a 4x. So we have 1/4 integral of 1 minus 1/2, and then 1 plus cosine of 4x dx. So 1/4 integral of 1/2 minus 1/2 is 1/2, and then minus 1/2 of cosine of 4x dx. So this now is, well, I see on the key they factor out a 1/2, so this is 1/8. You don't have to do this. This wouldn't be necessary, but we'll just kind of follow the key here. So 1/8, and then that's going to be x. The integral of 1 is x. And then let's see, it would have to have minus 1/4 sine of 4x is the antiderivative of negative, minus cosine of 4x. And then we have plus c. And that's actually how they left it on the key. That's letter C. Letter D. Let's see what we have for D. Integral of, it looks like, I'm kind of trying to interpret, is it secant squared tangent squared? I think it's secant squared x tangent squared x dx. And we're going to let u equal tangent of x because I see a function and its derivative. So u substitution is finding a function and its derivative, secant squared x dx. So this ends up being the integral of that secant squared dx becomes du. And the tangent is u, so that ends up being u squared. So 1/3 u to the third plus c. So 1/3 tangent to the third of x plus c. There's letter D. Then I'll tell you what, it gets considerably harder on this number 7 with trig substitutions for sure. Let's look at number 7, and I recognize this square root of x squared plus 25 as the Pythagorean theorem, or at least a version of it. And if this is theta, if this side's 5, this side is x, then the hypotenuse squared is equal to 25 plus x squared. So this side is the square root of 25 plus x squared. Let's let x equal 5. Well, no, let's do this. Let's do this. What I can write from here is the tangent of theta is opposite over adjacent, so x over 5. So from there we can write x is equal to 5 tangent of theta. And now if we square both sides, that'd be x squared is equal to 25 tangent squared theta. And then if we add 25 to that, x squared plus 25 is the same as 25 tangent squared theta plus 25. Well, we can factor out a 25 from there, and this is tangent squared theta plus 1. But tangent squared theta plus 1 is the same as secant squared theta. So the square root of x squared plus 25, if we square root both sides, is equal to 5 secant theta. So that gives us an opportunity to replace that square root of x squared plus 25. Well, let's go from right here, and we'll write if x is equal to 5 tangent of theta, then the derivative is equal to 5 secant squared of theta d theta. So now that allows us to make a bunch of replacements. So dx can be replaced with 5 secant squared theta d theta. X is 5 tangent theta, so x squared is 25 tangent squared theta. And then the square root of x squared plus 25 is times 5 secant of theta. So the 5's cancel out, and one of the secants cancels out. So we end up with 1/25. That's factoring this, or pulling that out of the integral. And then the secants cancel. So we're left with secant of theta over tangent squared theta d theta. Well, one of the things we can do with trig functions is turn everything into sines and cosines. So we have 1/25th integral of 1 over cosine of theta, and then times tangent is sine over cosine, but this is 1 over tangent, so this can be cosine squared theta over sine squared theta d theta. So this is 1 over 25 integral of cosine of theta over sine squared theta. Now we're kind of home free now. We can let u equal sine of theta, and then du is equal to cosine of theta d theta, and we have cosine of theta d theta. Let me get this arrow so I can scroll down a little bit. I'm kind of running out of room here. All right, so now we have 1 over 25 integral of, well, this is going to be 1 over u squared du. Yeah, is that right? Yeah, because that's the u squared. This is that's the du. 1 over u squared. Yeah, that works. So we have 1/25. This is u to the -2. So if we add 1, that's going to be negative u to the -1. So we have negative 1 over 25u plus c. Now we got to go figure out. U was the sine of theta. So that goes to negative 1 over 25 sine of theta plus c, which I'm going to go write the answer over here, all the way over here. Negative 1 over 25. And then we need, really, sine. 1 over sine is cosecant. So we really have, this ends up being cosecant of theta. But if we go back up to our triangle, SOHCAHTOA, right? So sine is opposite over hypotenuse. So we need hypotenuse over opposite. So that's going to end up being, can I write? Let's see, I can get the pen again. Square root of 25 plus x squared over x, and then plus c. So now we have number 9. Let's see if we can get this. Where did my cursor go? There we go. All right, well, now we have number 9. Let's go number 9. We have the integral from 0 to 8 of, this is dx over the third root of x to the 4th dx. So we're going to sneak up on 0. 0 is the problem because we can't divide by 0. Limit as a approaches 0. So integral from a to 8. Let's make it x to the -4 thirds dx. So we have the limit as a approaches 0. If we add 1 to this, add 3/3, that's x to the -1/3, and then times -3. And that's from a to 8. A to 8. So limit as a approaches 0 of, this is -3 over the third root of 8, and then minus a -3, so we could do +3 over the third root of a. But now this is -3 over, well, no, this one was 8, and then a. -3 halves, but then plus 3 over the third root of 0, and that's undefined. So this is undefined, so this one diverges. Let's go with letter B. Integral from 2 to infinity. Looks like 5 over x to the third dx. Yeah, it is. So now we have the limit as a approaches infinity. Let's make this, let's do this. 2 to a of 5x to the -3rd dx. And we're going to add 1 to this. So that's the limit as a approaches infinity of, that's going to be 5x to the negative 2, but then times negative 1/2 from 2 to a. So limit as a approaches infinity of negative 5 over 2a squared plus 5 over 2 times 2 squared. And when we plug infinity in here, if the denominator is going to infinity, this is going to 0. So plus 5/8. So this converges to 5/8. Oh, I had stuff down here. I kind of made room by pushing all that stuff down the bottom. And then finally, number 10. All right, there we go. Number 10. It says find the next two. Well, the next two are 3 over 5 to the 5th and 3 over 5 to the 6th, which is 3 over 3,125 and 3 over 15,625. So letter B, a sub n is equal to 3 over 5 to the n minus 1, because the first one is 3 over 5 to the 0. So if we're saying that a sub 1 needs to be 3 over 5 to the 0, that'd be 1 minus 1. That's where you get 5 to the 0.